The universe expands, yet the truth remains, still within.
What is the universe made of? Look around you for a moment. Everything you see appears solid and real. The ground beneath your feet, the walls around you, the air you breathe, and the stars shining in the night sky all seem like parts of a stable and understandable universe. For centuries, humanity believed that the world was made of simple and tangible things. Matter appeared to be composed of objects that could be seen, touched, and measured. But as science progressed and physicists began exploring the deeper structure of reality, a surprising discovery emerged. The universe is not made of what it appears to be. In fact, most of reality is invisible, mysterious, and still not fully understood. For a long time, scientists believed that atoms were the fundamental building blocks of matter. Atoms were once thought to be tiny, solid particles that could not be divided further. This idea made sense at the time because atoms were incredibly small and difficult to study. But as scientific instruments improved, researchers discovered that atoms themselves were composed of even smaller components. Inside every atom lies a dense nucleus made of protons and neutrons, surrounded by electrons moving through regions of space known as orbitals. These orbitals are not fixed paths like the planets around the Sun. Instead, they represent probabilities describing where an electron might be found. What surprised scientists most was the realization that atoms are almost entirely empty space. If the nucleus of an atom were the size of a marble, the electrons would orbit dozens of meters away. This means that the objects we experience as solid are actually composed mostly of emptiness. The reason matter feels solid is not because atoms are packed tightly together, but because electromagnetic forces prevent them from passing through each other. In other words, the solidity of the world is not a property of matter itself, but a result of interactions between invisible forces. As physicists continued investigating the structure of matter, they discovered something even more remarkable. Protons and neutrons are not fundamental particles either. They are made of even smaller components known as quarks, which interact through a force called the strong nuclear force. This force is one of the four fundamental forces of nature and is responsible for holding atomic nuclei together. Yet even quarks may not represent the deepest level of reality. According to modern physics, the universe may not be made of particles at all. Instead, the universe appears to be filled with invisible fields that exist everywhere in space. These fields are known as quantum fields, and every type of particle corresponds to a specific field. For example, electrons arise from the electron field, while photons arise from the electromagnetic field. In this framework, particles are not tiny objects moving through space. They are vibrations in these underlying fields. A useful analogy is to imagine the surface of a calm ocean. When the water is still, the surface appears smooth and empty. But when a wave forms, the water begins to move and create visible patterns. In quantum field theory, particles are like waves appearing in the fabric of these fields. They are temporary excitations rather than permanent objects. This idea completely transforms our understanding of what matter actually is. Instead of a universe made of solid particles, reality appears to be a complex network of interacting fields spread throughout space. But the mystery does not end there. When astronomers observe the large-scale structure of the universe, they discover something even more puzzling. The visible matter that forms stars, planets, and galaxies accounts for only a small fraction of the total mass in the universe. Measurements of galaxy rotation and gravitational lensing reveal that most of the gravitational influence in the cosmos comes from something we cannot see. This invisible component is called dark matter. Dark matter does not emit light, reflect light, or interact with electromagnetic radiation in ways that telescopes can detect. Yet, its gravitational effects are unmistakable. It forms vast halos around galaxies and plays a crucial role in shaping the large-scale structure of the universe. Scientists estimate that dark matter makes up about 27% of the universe. Even more mysterious is dark energy. In 1998, astronomers studying distant supernova explosions discovered that the expansion of the universe is accelerating. Instead of slowing down due to gravity, galaxies are moving away from each other faster over time. This means that space itself contains a form of energy pushing the universe apart. Scientists call this phenomenon dark energy. Dark energy appears to make up roughly 68% of the total energy content of the universe. When combined with dark matter, this means that about 95% of the cosmos is composed of substances we still do not fully understand. Everything we can see, stars, planets, gas, clouds, and galaxies, represents only about 5% of reality. This realization has dramatically changed our understanding of the universe. The cosmos is not simply a collection of visible objects floating in empty space. Instead, it is a complex and dynamic system dominated by invisible components whose nature remains unknown. Black holes add yet another layer of mystery to the composition of the universe. These objects form when massive stars collapse under their own gravity at the end of their lives. As the star collapses, its mass becomes concentrated into an extremely small region of space. The resulting gravitational field becomes so strong that nothing can escape, not even light. For many years, scientists believed that black holes simply swallowed everything that fell into them. But quantum physics suggests a more complex picture. According to theoretical predictions made by Stephen Hawking, black holes may slowly emit radiation due to quantum effects near the event horizon. Over extremely long periods of time, this radiation could cause black holes to gradually evaporate. This discovery created one of the most famous puzzles in modern physics, known as the black hole information paradox. If a black hole evaporates completely, what happens to the information about everything that fell into it? Quantum mechanics says information cannot be destroyed, yet black hole evaporation appears to erase it. Solving this paradox may require a deeper theory that unifies quantum mechanics and gravity. Some physicists believe that such a theory could reveal that space itself is not fundamental. Instead, space may emerge from deeper physical processes involving quantum information and entanglement. In certain theoretical models, the geometry of space-time appears to arise from patterns of quantum connections between particles. If this idea is correct, then reality may be fundamentally informational. Matter, energy, and even space itself could emerge from deeper patterns of information that define how the universe behaves. This possibility represents one of the most radical ideas in modern physics. The universe may not be made of objects at all. It may be made of relationships. As scientists continue exploring the cosmos, new observations and experiments will help uncover the true structure of reality. Powerful telescopes are observing distant galaxies formed shortly after the Big Bang. Particle accelerators are probing the smallest components of matter. Gravitational wave detectors are observing collisions between black holes and neutron stars, billions of light years away. Each of these discoveries brings us closer to understanding what the universe is truly made of. But each discovery also reminds us how much remains unknown. The universe is far more complex and mysterious than we once imagined. And the deeper we explore it, the more extraordinary it becomes. Still, within